Now let's look at the last example. This example is also from textbook on page 139. This is about healthcare organization. The process includes 5 different activities. There's some special information here if you pay attention to the table. So activity 1 or 2 can be done by technician, and 3, 4, and 5 has to be done by pharmacist. So when you combine activities, you have to be careful, which means you cannot really simply combine 2 and 3 because they have to be done by different people. So first we do the regular process analysis and try to identify the bottleneck. And then we want to figure out is there any better way we can do it. So we draw the flow chart. So 5 activities, 5 rectangles. So 1, 2, 3, 4, 5. So we copy the cycle time in seconds. So based on cycle time, we can calculate capacity. So capacity is equal to 1 over cycle time. To make things a little simple, we can do 3600 divided by cycle time because this is 36 seconds. It's 36 seconds. So for activity 1, the capacity is 150 per hour. For 2, it's 30 per hour. 3, 60 per hour. 4 is 90 per hour. Then 5 is 120 per hour. So what we did was just simply use cycle time to calculate capacity. The reason I use 3600 is because this is 3600 seconds per hour. So now look at these numbers so we can identify bottleneck activity. So what is bottleneck activity? The bottleneck activity can look at 2 different things. You can either focus on capacity, so look for the activity that has the smallest capacity, or you can look for the activity that has the longest cycle time. You will have the same conclusion. So if we pay attention to the capacity, we can see these are the capacities, 5 numbers. This one is the smallest one, so which means activity 2 is a bottleneck. If you look at cycle time, we see these are the 5 numbers. So this number is the longest cycle time, which also means activity 2 is a bottleneck. So activity 2 is a bottleneck activity. So then means the system capacity or the capacity for the entire process is 30 per hour. The system cycle time or cycle time for the entire process is 120 seconds. Okay. Next question, can we do better? Okay, so right now it's 30. The capacity, system capacity, 30 per hour. I wanted to remember this number. It's 30 per hour. So can we do better? Can we increase the capacity? The question, can we do better with 2 technicians and 2 pharmacists? Right now, with the current process, we need to hire 2 technicians and 3 pharmacists. So now the question is, if we hire fewer people, can we do even better? Okay. So with 2 technicians and 2 pharmacists, can we do even better? Let's take a look. So this is what we're going to do. What if we combine activities 1 and 2 into new activity? So as we recall from the table, 1 or 2 can only be done by technician. So we combine 1 and 2 and let a technician handle it. Same time, we combine activities 3, 4, and 5 and let pharmacists handle it. So that means at the same time, we want to schedule 2 people to handle each of the 2 new activities. So this is a new process. Combine 1 and 2, schedule 2 technicians. Combine 3, 4, and 5, schedule 2 pharmacists. So that's a new process. So with the new process, can we do better? The system capacity was 30 per hour. So with this process, hiring only 4 people, can we do even better? So let's do the calculation. So first of all, let's calculate the cycle time. So with 1 and 2, adding 1 and 2, what's the new cycle time? So cycle time for 1 is 24. Cycle time for 2 is 120. So we added these 2 numbers, we get 144. So 144 is the cycle time for the new activity 1 and 2. So what's the capacity? So new capacity is 3600 divided by cycle time 144, we have 25. So that is the new capacity for this new activity. Similarly, we can do a 3, 4, 5 pharmacist. So new cycle time, we add 3 numbers: 60 cycle time for activity 3, 40 cycle time for activity 4, 30 cycle time for activity 5. So we have 130. So that's a new cycle time. So with the new cycle time, we can calculate the new capacity. It's 3600 divided by 130, we have 27.7. So that's the new capacity. Now we need to identify the bottleneck and system capacity. So how to do it? We want to convert 2 rectangles into a single rectangle to make things a little more straightforward. So by combining 2 rectangles into a single rectangle, we copy paste the activity numbers. Cycle time will be shorter, capacity will be larger. Because we are combining the work for 2 people, cycle time was 144. Now we have 2 people, it's faster. The cycle time will be shorter. So the new cycle time is 144 divided by 2. We have 72 seconds. With 2 people, capacity will be larger, will be doubled. So it's 25 times 2 was 50. So new capacity is 50. So these 2 rectangles are equivalent to this new rectangle. Similarly, we can do the math for 3, 4, and 5. The cycle time was 130 with 2 people divided by 2, we have 65. The capacity was 27.7. Now we have 2 people, we double times 2, we have 55.4. So that is the new capacity. So look at these 2 different boxes, 2 rectangles. I have 2 different stages. We want to see which one is the bottleneck. We can look at the capacity. So this one has the smallest capacity, which is 50 compared to 55.4. So this is a new bottleneck activity. So new bottleneck activity is activity 1 and 2 because it has the smallest capacity or longest cycle time, 72 compared to 65. System capacity is 50 per hour. Okay, system capacity 50 per hour. So in the original design, the system capacity was 30 per hour. So now it's better. So with only 4 people hired, we can do even better than the original case when we had to hire 5 people. So that is the last example.